All right. A baseball diamond is not a diamond, it's a square 90 feet on all sides, 90 feet from home base, home base to first base, 90 feet to second base, and 90 feet to third base, and 90 feet to home. Suppose a player is advancing from second to third base at 24 feet per second. So that's that's a rate, 24 feet per second. An umpire is standing at home plate. Let theta be the angle between the third baseline and the line of sight of the umpire to the runner. So I've got a runner out here running to this player, and this is the angle that we're looking at. Straight to the umpire. How fast is it changing when the runner is 30? Oh, wait a minute. From second, oh, the runner's going from second to third. I got him over in the wrong place. Move the runner over here. You standing in the wrong place. He's running here at 24 feet per second. And so the angle is here. I was worried it would have been harder to do this one. This is a right triangle. The angle is here. And if this is 90 and this is what's changing, so we're going to call it x. See, x over 90, I believe, is the opposite over adjacent, is the tangent of the angle. And now we have it where this is changing, so we don't use this rate or any place. We take the derivative, so this is 1/90th. Derivative of x is dx dt equals derivative of tangent theta is secant squared theta d theta dt. So now we can do some of the things that we're changing. He was 30 feet away when he was going 24 feet per second. 30 feet. So we can get the angle that he was at this when he was going that fast. And we need that angle to figure out how fast the angle is changing when he's going this 24. So this is the 24 feet per second. 1/90th is a number. We need to know the angle when he was 30 feet away. So we're going to do tangent inverse of 30 divided by 90, opposite over adjacent. 30 divided by 90 is 1/3. So make sure my mode's in degrees, yes. So we're going to go second to get tangent inverse of, I'll just do 30 divided by 90. And it says the angle is 18.435. So if we do the secant squared, or 1 over the cosine squared, and then multiply both sides by 1 over 1 over secant squared, which is times the cosine squared, we'll get what the angle is changing at. So I've got to do cosine of 18 point, I can just use of the answer squared. Quotient would be in the denominator, which goes in the numerator. That divided by 90 times the 24 feet per second. And I get the angles changing at 0.24 degrees per second. 0.24 degrees per second. Now, I don't know whether they wanted it in radians or in this. We'll leave it in degrees. Okay. And finally, this is one of them I mentioned. Sand is being dumped off a conveyor into a conical pile. Very typical problem. In a way that forms a cone whose radius is always equal to the height. Height, radius. And assuming the sand is being dumped at 10 cubic feet per minute. So that's a rate. That's dV dt. So we can't use it until we take a derivative. How fast is the height of the pile changing when there is this volume in the pile already? So we're going to go for the volume of the cone, which is 1/3 pi r squared times the height. And the radius and the height are the same. So and it says, how fast is the height changing? So we want to keep h. So we're going to put h's in for the r's instead of r's for the h's. So we're going to have v equals 1/3 pi h cubed, taking the derivative. The change in the volume with respect to time is 1/3 pi 3h squared dh dt. dH dt is what they wanted us to find. How fast is the pile changing? When the volume is, so we have to go back here and put 1,000 and figure out, we're going to actually do it here and figure out how high it was, because we need a height. And we're trying to figure this out, and we need the change in the volume, which they said 10 cubic feet per minute. So 10 goes here. We have to figure out h to put it in here using the 1,000, and then we can solve for this. So first, I've got 1,000. I got to multiply by 3 to get the third out of there. I got to divide by pi. And then I've got to get that answer. So this over here, and then take the cube root. To the 1 divided by 3 power. So that's how high the pile was, 9.847 feet. Now to figure out how this is changing, I got to figure this number out, which means I got to square the height. So I got to square this answer. Take it, the 3 and the 1/3 are going to cancel, so just take it times pi. And that's what this number will be. And I got to divide that into 10. That's how fast the volume is changing. So 10 divided by that answer gives me the height changing at 0.328 feet per minute. 0.0328 feet per minute.